Hi, welcome to MPT Tech Talks, where we're talking about everything to do with battery development. In this particular case, we're talking about the challenges of testing battery packs and drive cycle testing at MPT. And I'm joined today with Marco Proietti, Development Engineer of 6 years at MPT, and joined the business through our graduate scheme. So, nice to meet Marco, and hopefully do today. So, today we're going to be talking about battery pack testing and what we can do at MAHLE Powertrain. So, what's your role within MAHLE Powertrain?
So I'm overseeing the new battery development centre, which is newly commissioned.
Okay.
Dealing with customer testing at the moment, which is basically I liaise with the customer. We come up with test plans, we come up with instrumentation requirements, and we then put those test plans into action, run the tests, process the data, send the data to the customer, and then in a development project we'll come up with our own sort of test plans internally, or they may be customer defined test plans. We're capable of performance, thermal, and software testing in the facility.
Okay, so what's the purpose of the kinds of tests that we can actually do within the test facility or battery development centre at MAHLE?
So the main purpose is the battery pack performance testing. So a large part of that is thermal performance. So we have the capability of going to really low sort of cold soak temperatures and high temperatures to simulate winter and summer conditions in different climates. And we can have a look at the battery performance. So in a cold climate, you'll get a much lower sort of battery capacity. And in a hot climate, you'll be pushing the batteries to their thermal limits. And you may get some derate within the battery in the software that limits the sort of power that you can produce. So it's really important for us to go through the thermal cycles, which can be defined by the customer or by ourselves based on different drive cycles.
Okay.
We'll also do some drive cycle performance testing. So this will be data that's captured from actual vehicles, which we then feed back in auto cycles to our test facility, and we can run those continuously, replicating actual like in-field data that's collected.
So running charge and discharge rates
so
as it's going round, say, a track or a drive cycle route or something
exactly,
like that.
Depending on the vehicle,
Okay. That's interesting. So that we can sort of validate the battery pack before it's even got into a vehicle, so you can sort of simulate how it's going to perform within the vehicle.
And any hardware or software changes on the battery pack, it's a great first step, initial step to take that battery pack and test it at our facility rather than the expense of fitting that to a vehicle in the field.
Okay.
Yeah.
So what's the main challenges that we face then when we're testing battery packs?
So one of the challenges we've got is the BMS, the software in the battery, is quite complex. There are a lot of different limits. So we have dynamic limits. We have the pack sort of hard limits that we have to consider. We have to feed these through to our automatic battery cycler controls. We then have to consider a drive cycle. So that may be something that we have sort of 1 hertz data from the field, which we've then got to feed into an auto cycle. We want that to run autonomously. So one of the big things is having a robust safety system so that we have full confidence that the batteries can be pushed to their thermal limits and continuously do that for hours and hours on end without any risk of fire, because or any sort of damage or anything that would put anyone at risk, because I think everyone knows that batteries, lithium-ion batteries, there's a real risk associated with them. If they set on fire, it's really difficult to put out, and it's something where there's a lot more channels. Although it's quite a simple pack with not so many components, when you compare it to something like engine testing. You do monitor a lot of different cells, so you may have thousands of cells in a pack, and you have to monitor a select few. You have to instrument like high voltage carrying components like the bus bars, and you have to tie those all into the test bed and be able to monitor them all the time, have the correct alarms and limits set, and have the safety systems in action.
Okay. So what's the size of battery pack, and what's the limits that we can actually test here at MAHLE Powertrain?
So our facility has been designed to take quite large battery packs. If we're thinking about a passenger vehicle, Typically, the battery packs will take up the kind of whole floor plan of the car, of the vehicle. So we have a large tank that can cope with that. But it's, there's a lot of modular batteries where we'll be testing smaller or larger, so it's quite adaptable for that. In terms of the
electrical performance, is it up to 1 megawatt, I believe?
Yeah, I think it's 1 megawatt
for a whole battery pack,
peak power. Yeah, nice. So it's pretty capable. There's, I don't know of anything in the field at the moment that could not be tested here.
Yeah, that sounds like it should cover most applications, really. So safety is a big paramount thing, really, when testing battery packs. So how do we keep people safe?
Yeah, so the first thing is we need the appropriate training for everyone.
Yeah.
We need the appropriate PPE and equipment around. So whether we're reworking a battery pack, we have the correct tools, we have the correct PPE for working on batteries, performing safety checks in the test cell, which we'll be doing quite often, and that everyone's aware of what they need. Robust safety systems that are, as I said, they're autonomous. We have sensors that can sense any fumes from a burning battery pack. We have CCTV installed. So we have all of these measures in place, which should mean that there's no manual intervention and the chance of any sort of human error when it comes to the safety side of it. We should be able to capture everything through our safety systems and keep everyone safe. And that's the idea, is the least interaction possible, human interaction with the battery packs themselves. But also we have really robust procedures which we can follow, which means that everyone fully understands what they're supposed to be doing, what can keep them safe, and if there is anything dangerous, we have the people with the correct training and the knowledge that can advise.
Okay, so we can guide our customers through that as well.
Yeah, exactly. And it's not just while we're testing the batteries. When the batteries are in storage, we need to make sure that they're monitored. So we have regular checks. We have some expensive storage facility which can monitor them and is safe and approved for storing sort of high energy battery packs.
Yeah, okay. Just one question again on the drive cycle side of things.
Yeah.
If we're running a drive cycle within the battery development centre, just on the battery alone, I'm assuming that we can then replicate that drive cycle again in the vehicle development centre once the battery pack's in the vehicle, and do exactly the same drive cycle.
Yeah, so it works in a similar way, that you'll have a request which will have the drive cycle in it, and we can essentially import that into our cyclers, or we can import that into a test program on the dyno, and we can repeat that then. So that just furthers the validation.
It's really good. So it gives MAHLE Powertrain a big capability having the battery development centre in-house, and matches up with all our design and analysis capabilities. Really fits within the design process or the battery development process that we've come up with at MAHLE Powertrain.
Yeah, definitely.
Thanks for your time, Marco. Appreciate that today, and thank you for listening to this MPT Tech Talk. If you want to know more from myself or Marco about battery development at MAHLE Powertrain, please don't hesitate in contacting us.